All right, guys. So today we're looking at finding all 6 trig functions evaluated at a given angle. The big thing here is that we don't know what angle is given. So we'll always have 2 pieces of information, and each of those pieces tells us something major about the rest of the trig functions. So we'll use those 2 things to try to come up with something a little more general. So you do need to remember which trig functions are positive in each quadrant. You hopefully remember from our last class that we said all are positive in the first quadrant. The sine and its reciprocal, cosecant, are positive in the second quadrant. Tangent and its reciprocal are positive in the third quadrant, and cosine and its reciprocal are positive in the fourth quadrant. So this is like our little chart of which is positive. Right, that's what this chart gives us. It's also very important to remember that if something isn't positive, that means it's negative, right? So I'm going to just list, since cosine is, secant also is, since tangent is, cotangent also is, and then with sine comes cosecant, right? So that being said, the first thing I'm looking at is this piece of information right here. Sine of the angle is 3/5. So this says find the quadrants where sine is positive. That means I'm dealing with quadrant 1 because they're all, or quadrant 2, right? See this? So I'm dealing with either of these 2 quadrants. I'm not sure which, but that first piece of information tells me that angle, the angle theta, has to be in either the first or the second quadrant. The second piece of information right here says that cosine is negative. That means we're dealing with either the second quadrant or the third. So we're talking one of these 2. And notice that information, the blue and the red information, overlap in the second quadrant. So what that does, that tells us that we have this place. The second quadrant is where this angle theta must be, because that's what's common to both pieces of given information. So as soon as we have that identified, we're going to use that to draw our triangle. So here we go. I have some angle over here. Here's my theta. And then we drop a vertical down to the closest x-axis. See the triangle? And we're going to use this little guy in here. I'm going to call it theta r, the reference angle or the reference theta. And then label my triangle with the other given information, right? So we were told that sine of that angle theta is actually 3/5, right? 3 and then fifths. The reason I have 3/5 there, 3 on the vertical and 5 on the radius or the hypotenuse, is SOHCAHTOA. Remember that? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I'm just trying to use some colors here to remind you what's going on. You've got opposite over hypotenuse, right? That's where all that stuff is coming from. It's a little hard to read. There's a 3 there. So if I have that much, I should be able to come up with whatever this leftover angle is down here, right? I should be able to figure out, the leftover side. So I can find the other leg right here by using the Pythagorean theorem. So I'll say that the leg, one of the given legs squared, plus, this is the thing I'm looking for, I'll just call it x squared because it's the x value if we're thinking about x and y. So x squared should be equal to 5 squared, right? And then, of course, we've got 9 plus x squared equals 25. Do a little bit of algebra here. You can take away the 9. Right, we're solving this equation. We get x squared is equal to 16. And since it's a side of a triangle, we end up with just plain old x equals 4. Right? Algebraically, you get positive and negative 4. But again, because we're dealing with a side of a triangle, it's just 4. Now, I know most of you know 3, 4, 5 is a Pythagorean triplet. I just showed you the work in case these numbers aren't really nice, clean numbers. So now, what we're being tasked to do, of course, is to find the sine at theta, cosine at theta, tangent at theta, right? All of these things. Cosecant at theta, secant at theta, and then cotangent at theta. The reason I'm listing them this way, I just find it to be a lot easier to just fill out a chart. We were given sine, so I'm just going to fill that in. Let's use a pink to show that these are answers, right, that we're coming up with. So it's 3/5. The cosine, I can actually just use my triangle here, right? And you know what? I'm thinking it's probably best that I just use the colors that I labeled this triangle in for each of these things. So I'm gonna just scribble that out and say, you know what? Let me do 3 over 5. And hopefully you can follow the colors and where they're coming from then. I'm going to jump to the cosecant because it's just the reciprocal of sine, right? I can write this down, and truth is I could have labeled these two without doing any of the work I just showed you, because I was given 3/5 for sine, and I can flip it. I can do the reciprocal for cosecant. The other ones I need to use the triangle. So cosine, we know from our right triangle trig back in the day, cosine is going to be the adjacent over the hypotenuse. So that's 4, right? There's the adjacent over 5. And if I have cosine, I should just label secant. It's just a reciprocal. So that's 5/4. And then the only one left, is tangent, and then we can do reciprocal for cotangent. And then we're looking at SOHCAHTOA here, right? So opposite over adjacent means we should have 3 over 4 for tangent, and then 4 over 3 for cotangent. So hopefully you can use this information to get all the rest of the problems on the worksheet for today. If not, do your best, and we'll touch base again tomorrow when we have class in person. Right? Good luck.